What you're about to see is a cross-chain swap, trustless, peer-to-peer, and verified by RealityNet. There's no bridge, no wrapped ETH, no liquidity pools, just two people who want to trade and a protocol that makes it happen safely. In this case, one user holds ETH, the other holds NET. Each has an Ethereum address and a RealityNet address. They both submit swap requests. One is selling ETH for NET, the other is selling NET for ETH. RealityNet listens, matches the two intents, and generates a digital receipt, a match hash, proving the deal. Now, in this demo, the ETH is sent manually using MetaMask on the Sepolia Ethereum testnet. In production, this entire flow will be automated through the Reality Portal app. What you're seeing here is the raw infrastructure, the core mechanics that make atomic cross-chain swaps possible with no custodians, no slippage, and no centralized control. Let's dive in. We are running two clusters, one for RealityNet and one for Ethereum. The RealityNet cluster handles the intent logic, submitting, verifying, matching, and settling swap requests. The Ethereum cluster, or what we call the rApp cluster, listens to the Sepolia testnet, tracking ETH transfers as they confirm on-chain. You can see here each node runs on its own port, proving these are real independent processes working together without relying on a single source. Validation happens in parallel, with every node verifying what it sees on its own. All right, before the swap begins, we check the wallets involved. Here you can see two RealityNet addresses, each with a balance of 2,000 NET tokens. This confirms that both users have enough to participate in the trade. One of them is about to offer 750 NET in exchange for ETH. The other user will be sending ETH from their Ethereum address and receiving that 750 NET on RealityNet once the trade is confirmed. All right, what you're looking at here is the raw transaction layer. These are three separate signed messages submitted via command line. The first is a sell request. It's offering 750 NET in exchange for 0.0011 ETH. What we're demonstrating here is a swap between two different people. Each request comes from a separate wallet with its own private keys and address. And here is the second request, which is the buy request. This person wants to sell 0.0011 ETH in exchange for 750 NET. At the very bottom is the fulfillment transaction, and that only gets submitted after the ETH has been received and confirmed on-chain. Now, in production, all this will be inside the Reality Portal app, clean, simple, and fully automated. You'll see something here called a foreign address. That just means an address on another chain. For example, a RealityNet swap request might include a foreign Ethereum address so the protocol knows where to send or expect ETH. All right, now we're going to send that second swap request, the buy order. For the match to go through in this demo, the values have to align exactly, same amount, same assets, opposite directions. But in production, RealityNet will use a matching algorithm that can split orders and combine them across multiple parties. That means even partial swaps can still be fulfilled trustlessly. All right, now we call the match swaps endpoint. The protocol sees both requests are a perfect match, and it generates a match hash to lock in the trade. This is proof that the swap is now ready to be fulfilled, and the hash is now visible to both clusters. All right, now we're switching over to MetaMask, where you can see two Ethereum accounts. That's the seller, the one ending in 862. And these are the same addresses used in the original swap requests. All right. This confirms that each request was signed by the actual owner of the wallet. It's not just simulated. MetaMask is connected to the Sepolia testnet here, and we're about to send the ETH required to fulfill the match. That's the person B. He's the net holder, right? So person A is the ETH holder. They're swapping ETH for NET. They're the ones who sends ETH using MetaMask. Once it's confirmed, they'll receive NET on RealityNet. Here it is. He's sending it here. Only one party sends ETH, right? The one who's swapping it for NET. That ETH is sent directly to the recipient's address as defined in the match hash. Once it's confirmed on-chain, RealityNet validates the transaction and finalizes the swap. Here we're waiting for it to settle. Now in production, all this will happen inside the Reality Portal app. People will be able to connect wallets from any chain, Bitcoin, Ethereum, Solana, and the flow works the same way, secure, atomic, and trustless. Once the net holder submits their swap request, this 750 NET is locked by the protocol. It's held in escrow by RealityNet itself. It cannot be withdrawn or redirected. It's frozen until the ETH is received. When the ETH is sent and confirmed on chain, RealityNet releases the net to the sender. This guarantees that both sides of the swap are fulfilled or nothing happens. All right, now we're picking up after the ETH has been sent. The protocol is watching for that ETH transaction to be finalized, in this case on the Sepolia testnet. Once that block is confirmed, the Ethereum rApp cluster detects the fulfillment. We grab the ETH transaction hash and submit it along with the match hash. This proves that the ETH side of the swap was fulfilled. The Ethereum rApp cluster handles it first before anything gets passed to the core RealityNet cluster. The rApp cluster takes a snapshot of the chain, pulls in the ETH transaction, and confirms that it matches the original swap intent. Once the block is finalized, we see it, along with all the relevant metadata like the block hash and fulfillment state. And from there, the rApp verifies that this ETH transaction matches the swap request. Right amount, right address, link to the original deal. Only then does it pass confirmation to RealityNet, unlocking the next step of the swap. Now, we are waiting for the Ethereum transaction to be picked up by the rApp cluster. Even though the ETH has already been sent and the block is finalized, the system still needs to detect it, pull in the transaction, and confirm that it matches the swap request. All right, here we're showing that the transaction landed in snapshot number 131. The snapshot call is being triggered manually here, but in production, this would all happen automatically. The rApp would continuously listen for fulfillment events and update the system in real time. That extra step is what makes the swap atomic. Until both sides are confirmed, nothing moves. All right, now we're showing how the hash matches. If you look closely, the transaction hash from Etherscan matches the exact same block shown in the Ethereum rApp cluster, proving that the transaction was finalized and verified on chain. All right, now we return to look at the global state, and you can see the two net balances. It's refreshed, and there it is. The ETH sender receives their 750 net. The net sender's balance decreases accordingly. You'll also notice one token missing. That's the fee for the fulfillment transaction, which in this demo was paid in net. It was just one token. But here's the most important part. The swap has been fully executed. No bridges, no wrap tokens, no AMMs, no centralized intermediaries, just peer-to-peer atomic settlement across chains. There's no slippage, no impermanent loss. You can retire those phrases. They don't exist anymore. And this works across Solana, Bitcoin, Ethereum, any digital asset to any other digital asset. And all permissionless sources of liquidity become reality liquidity. This is your first look at how RealityNet solves the golden goose problem in crypto. This is a global DEX that unifies all liquidity across the entire space. And it can plug into any Web2 API. I mean, can you imagine the new DeFi primitives that'll be invented with this tech? Because we can, and now anyone can build with it.